Hi and welcome to this video on graphs, straight line graphs and how to draw graphs. So straight line graphs have a standard formula y equals mx plus c, where m is the gradient or the slope of the graph and c is the y-intercept. Straight line graphs, when they're written, as y equals mx plus c, have something x, something y, and a number. There's no xy or x squared or y squared or x cubed or a square root of x or 1 over x. If there is, then it's not a straight line. Rearranging the equation is a nice way to find out if it fits the standard form of y equals mx plus c. So here we have 2y minus 4x equals 8. We keep the y on the left hand side, move the 4x across, so that becomes plus 4x. So we get y equals 2x plus 4 when we rearrange that by dividing by 2. X minus y equals 0. Keep the y on the left hand side, take the x over to the other side, and it becomes y equals x plus 0, which fits the form y equals mx plus c. M is 1 and c is 0. 12x minus 18 equals 6y. Try and bring the 6y onto the left hand side, and that becomes 6y equals 12x minus 18. Divide through by 6 to get y by itself. Get y equals 2x minus 3, which fits this form y equals mx plus c. Just a quick reminder that when we're drawing graphs, our horizontal line is x and our vertical line is y. So this point on the x is 6, this point on the y is 4. So we go across 6, up 4, and the coordinates of this point are 6, 4. This is the x-axis, this is the y-axis. When we draw a horizontal line here across y equals 4, when we draw a vertical line here, this is x equals minus 6. Some easy ways to draw graphs. If we're asked to draw a graph y equals 2x minus 2, choose 3 values of x. Here we've chosen 0, 2, 4, and then work out the y value. So if we put in 0 here as x, we get y equals minus 2. If we put in 2, 2 times 2 is 4, 4 minus 2 is 2. If we put in x as 4, we have 4 times 2 is 8, 8 minus 2 is 6. Then using this table, we then get the xy coordinates, 0 minus 2. So here we have 0, here we have minus 2. Mark that point. 2, 2, which is here. Mark that point. 4, 6, which is here. Mark that point. And then draw a straight line through the points. The second easy way to draw graphs is let x in the equation equal 0 and then let y equal 0. So here if we have 4x plus 3y equals 12 and we let x equal 0, this term becomes 0. We have 3y equals 12, so divide through by 3, y equals 4. If we have y equals 0, then this term becomes 0, 4x equals 12, divide through by 4, then x equals 3. We plot the 2 points that we've got and connect them with a straight line to draw our straight line graph. Because we know a straight line has the standard form y equals mx plus c, if we have the equation y equals 2x plus 1, we know where it crosses the y axis, it's going to cross at c, which here in the equation is 1. So we mark y as 1, 0, 1 on our graph. Then we know that m is the gradient, so m is 2. Now the gradient is the y units divided by the x units, or the rise over the run. So from our point that we have, which is 0, 2, we go 1 across, 2 up, 1 across, 2 units up, mark our point here, mark our point there. Now we've got 3 points and join them with a straight line. Sometimes in the exam we're given a table of x values and we're given one y value that there is corresponding to that x value. So here we're given xy as 1, 0. And our formula is y equals x squared minus 4x plus 3. This isn't a straight line because it's got x squared in it, but we're asked to draw the graph. First of all, what we do is we check our calculation to make sure that we're going to do it right. So for using 1, we put 1 squared plus 3 minus 4 and then multiply by 1. Work that out, it becomes 4 minus 4 equals 0. So we know that our calculation is going to be right. Then we use each x value in turn. So here we're going to use minus 2. So minus 2 squared is 4. 4 plus 3 is 7. So we put our 7. Then minus 4 times minus 2 plus 8. So 7 plus 8, 15. So this value here would be minus 2, 15. So when we plot those points, draw a smooth curve through the points, and we've drawn our graph. Just as a matter of interest here, this is a parabola. This is a quadratic equation. It's got an x squared in it. The vertex is given by minus b over 2a. The a is the number attached to the x, and the b is the number. The a is attached to the x squared, sorry, and the b is attached to the x. So this becomes minus 4 over 2. And that gives us, so minus minus 4, which is 4 over 2, which is 2. Don't forget that we're going to minus b. Okay, let's have a practice if we can imagine what these straight lines will look like if we're given an equation. So if we're given 2y minus 4x equals 7, what's it going to look like? Well, let's arrange it with the y on the left hand side. So we get 2y equals 4x plus 7. We take the 4 to the other side. It becomes a 4x plus. Then divide through by 2. We get y equals 2x plus 7 divided by 2. Then what we do is we have it in the form y equals mx plus c. So our m is 2. We know the graph's going to have a positive gradient of 2, and it's going to cross the y-axis at plus 7 over 2, which is 3.5. So it's going to look something like this with a gradient of 2. And it's going to cross the y-axis at 3.5. So a line plus 2 crosses the y-axis 3.5. 6y minus 6 minus 7 equals 0. Is it a straight line? When we rearrange it with the y on the left hand side, we get 6y plus x plus 7. Divide through by 6 to get y by itself. So this is y equals 1/6 of x plus 7 over 6. So yes, it does look like y equals mx plus c, so it's a straight line. Crosses the y-axis at 1.01, which is 7 over 6. And it's got a positive gradient 6 units across, 1 unit up, which is going to look a little bit like this blue line. When we draw it, this is the line we get. Is this a straight line? Let's multiply through by 5. We get 5x plus 15y equals 5. Rearrange to get y on the left hand side, and we get this. Does it look like y equals mx plus c? Yes, it does. So it's a straight line. It crosses the y-axis at plus 5 over 15, which is around about plus 0.33. It's got a negative gradient, so it's a downward slope, and it's going to look something like this blue line. Negative slope of -3. Sorry. There we go. When we plot the points, we get that.